For any game to be effective, the playing area needs to be limited to certain dimensions. Cells are also limited to a certain range of sizes. If they grow too large, they become unmanageable. For one thing, the nucleus, the control center, simply can't handle the unlimited activity. But perhaps even more important is the role of the cell membrane. As a cell grows larger, the efficiency of the membrane decreases.
But cells do grow, don't they?
Within limits. As a cell grows, its volume and contents increases more rapidly than its surface area.
The volume inside increases much more than the surface area that expands around it.
Compared to the volume, the surface area becomes relatively smaller and smaller. If growth continues, the membrane will be overworked. It won't be able to transport all of the materials that its growing contents demand in and out of the cell. Finally, it may even rupture. So there's a limit to the amount of volume a cell surface area can sustain. A higher ratio means more surface area to volume. That means more efficiency when it comes to exchanging heat, gases, nutrients, and wastes with the cell's environment.
Surface area affects all kinds of structures. A car radiator has a lot of surface area to dissipate heat. It keeps the cooling system cool.
An elephant's ear is a natural radiator. The large surface area of exposed skin allows faster heat loss when the animal warms up.
And remember the alveoli in our lungs? The more surface area in contact with capillaries, the faster oxygen enters the blood.
If these two cereal boxes were cells, which would be more efficient?
The one with more surface area for less volume.
So the higher surface area to volume ratio?
Mm-hmm. Now let's eat.
First, let's work it out.
John and Rennell find the total surface area by adding the areas of each side, and find the volume by multiplying height by width by length.
The small box has a surface area to volume ratio of 320 square centimeters over 350 cubic centimeters.
The bigger box has a lower ratio. It's 1,900 square centimeters over 4,400 cubic centimeters.
So if these were cells, the smaller box would be more efficient because its surface area to volume ratio is higher.
You've got it. Now go ahead and expand your surface area.
Okay.
Science rules.
You know that a larger cell is less efficient than a smaller one. But what can you say about a multicellular organism, the whole plant or animal? Is it affected by its overall surface area to volume ratio? Take these two organisms. Can you predict the difference in their metabolic rate, the rate at which they convert and use energy? Remember, larger cells are slower to respond and less active than smaller ones. In fact, the same principle applies to whole organisms. The moose has a lower surface area to volume ratio and a lower level of activity than the mouse.